Good evening, dear students. Our next part, that is regarding the electrophilic substitution reactions of pyrrole. We have been discussing the reactions of pyrrole, isn't it? So next is electrophilic substitution reactions of pyrrole. First of all, write the formula for pyrrole. NH, two double bonds. So this is a pyrrole ring. Then the first electrophilic substitution reaction, that is chlorination. Chlorination. Okay. So chlorination, here we will be using S2Cl2. S2Cl2. And here we will be having, see, at these positions there are 4 hydrogen atoms, right? 4 hydrogen atoms are there. So these 4 hydrogen atoms, they are replaced by this chlorine atom. Okay, the 4 hydrogen atoms at these positions, that is 1, 2, 3, 4 and 5. So 4 hydrogens are there at 2, 3, 4 and 5 positions. These 4 hydrogens, they are replaced by this chlorine. Okay, so the compound will be like this, NH. A double bond will be there. Double bond is not substituted. Hydrogens will be replaced by this chlorine. Okay, so the compound is 2, 3, 4, 5 tetrachloropyrrole. 2, 3, 4, 5 tetrachloropyrrole. Okay, then the next reaction, that is bromination. Bromination, here the reagent used is bromine in methanol, CH3OH, bromine in methyl alcohol. Here also the same reaction, the hydrogens, the 4 hydrogens, they are replaced by 4 bromine atoms. NH, double bond, then at the 2, 3, then 4 and 5, 4 bromines will be there. So the compound is again 2, 3, 4, 5 tetrabromoPyrrole. Okay. Then the next is iodination reaction. Similar reaction. Iodination reaction. Here the reagent used is iodine in presence of sodium hydroxide. The same reaction again. Hydrogens are replaced by 4 iodine atoms. Again the compound name is 2345 tetraiodopyrrole. 2345 tetraiodopyrrole. Then the next reaction, that is the nitration reaction. Nitration reaction, see here the reagents are, in any case for nitration we are using nitric acid, isn't it? Nitric acid in presence of acetic anhydride, AC2O. AC2O means acetic anhydride at a temperature of minus 10 degrees Celsius. That means it is an ice cold solution. The temperature is less than that of ice, isn't it? Minus 10 degrees Celsius. So nitration, normally these electrophilic substitutions will be taking place at the second position in the case of pyrrole, isn't it? Electrophilic substitution at the second position. So here the product will be like this, NH, at the second position NO2 group. Okay. So the compound is 2-nitropyrrole. 2-nitropyrrole. Okay. Then the next reaction, sulfonation. Sulfonation. Sulfur trioxide, then pyridine. Sulfur trioxide in presence of pyridine at a temperature of 100 degrees Celsius. Again, at the second position, SO3H group will be introduced. NH, at the second position, SO3H. So the compound is pyrrole 2-sulfonic acid. Pyrrole 2-sulfonic acid. Then again the next reaction, Friedel-Crafts reaction. Friedel-Crafts reaction normally it will be an alkylation or an acylation, isn't it? So Friedel-Crafts reaction. Friedel-Crafts reaction in presence of acetic anhydride and stannous chloride SnCl4. Again here the group introduced is acetyl group, okay, COCH3 group. That is at the second position COCH3 group will be introduced, since Friedel-Crafts acylation or acetylation, COCH3. At the second position COCH3 group is introduced, so the compound is 2-acetyl pyrrole. We had seen so many similar reactions in furan as well as thiophene, right? So here also the reaction it is 2-acetyl pyrrole. Then the next reaction, that is the Kolb's reaction. Kolb's reaction you might have studied in your plus 2 itself, isn't it? Kolb's reaction, the reagents are carbon dioxide at a very high temperature and under pressure. Kolb's reaction. So for Kolb's reaction what happens is that this compound, this pyrrole, at the second position COOH group will be introduced, or this CO2 will be introduced at the second position. Okay, see, at the second position there is already one hydrogen atom. Okay, so to that position CO2 group is introduced, so it becomes COOH. Okay, so the compound, the product will be like this, NH, then at the second position COOH. Okay, so the compound is pyrrole 2-carboxylic acid. Pyrrole 2-carboxylic acid. Okay, so this is Kolb's reaction. In presence of carbon dioxide at very high temperature and pressure, CO2 group will be introduced at the second position, so that the compound becomes pyrrole 2-carboxylic acid. Next is also another famous reaction, that is the Riemer-Tiemann reaction. For Riemer-Tiemann reaction, the reagents used are chloroform and alkali, isn't it? Again pyrrole, NH, Riemer-Tiemann reaction. I think there is no hyphen at this position, sorry. RIEMER, Riemer-Tiemann reaction. Riemer-Tiemann reaction, the reagents used are chloroform and alkali, CHCl3 and KOH. Okay, chloroform and alkali. So for Riemer-Tiemann reaction, the product will be CHO group will be introduced at the second position. Okay, for any Riemer-Tiemann reaction, an aldehyde will be the product. So here also CHO group will be introduced at the second position. So the product will be like this, NH, at the second position CHO. Okay, so the compound, this is this group, CHO group is formyl group, isn't it? It is an aldehyde group. So this compound is 2-formyl pyrrole. 2-formyl pyrrole. Okay, 2-formyl pyrrole. Then the next reaction, again introduction of an aldehyde group. So the reaction it is Gattermann formylation reaction. GATTERMANN. Gattermann formylation reaction. So the term itself says that it is the introduction of the formyl group or CHO group, right? So the reagents for this Gattermann's formylation is HCN/HCl. Okay, Gattermann's formylation. So here also a formyl group is introduced. The reagents used are hydrogen cyanide and hydrogen chloride. Again at the second position CHO group is introduced. NH, then again CHO. So the compound is 2-formyl pyrrole. 2-formyl pyrrole. Okay. Then the next is coupling reaction. Coupling reaction. See here, for coupling reaction, the reagent used is benzene diazonium chloride, ArN2Cl, or C6H5N2Cl. This is benzene diazonium chloride. Okay, benzene diazonium chloride. benzene disonium chloride ArN2Cl. So this ArN2Cl, benzene disonium chloride, it is a very important reagent used for coupling. We had seen in our last semester, right? These coupling reactions, isn't it? So here at the second position, what happens? This ArN2 group will be introduced at the second position. Okay, that means at the second position, one hydrogen will be there, and this hydrogen along with this chlorine atom will be eliminated as HCl, so that this compound will becomes at the second position N2C6H5. Okay, so the compound will be like this, NH. Then again N2C6H5, that is N double bond N C6H5, or here you can write it as C6H5 or ArN2Cl. Okay, so the product will be like this. So at the second position, hydrogen will be eliminated as HCl from this disonium salt. Okay, so you will be having this compound, and the compound is aryl azopyrrole, aryl or benzyl. Okay, aryl, not benzyl, it is phenyl. Aryl azopyrrole. Aryl azopyrrole. Okay. Then the next reaction, that is the mercuration reaction. Mercuration reaction. Mercuration reaction. See here, we will be using acetyl mercury CH3COO twice Hg in presence of acetic acid CH3COOH in presence of acetic acid and heat. Okay, so the product will be NH, then at this position HgCOOCH3. Okay, HgCOOCH3. This one HgCOOCH3 will be introduced at the second position. So this compound is 2-acetoxy mercury pyrrole. Mercury pyrrole. 2-acetoxy mercury pyrrole. Okay. So these are the electrophilic substitution reactions, and you have to study the reagents. So see, Rimer-Tiemann reaction, the reagents are, see this named reactions, they are very important. Please don't skip the named reactions. So for Rimer-Tiemann reaction, the reagents are chloroform and alkali, and for Gattermann formylation, the products will be the same, that is 2-formyl pyrrole, that is at the second position CHO group is introduced. Then coupling reaction, it is benzene disonium chloride, the reagent used. Then we will be having aryl azopyrrole. Then the next is mercuration reaction, we will be having 2-acetoxy mercury pyrrole. Okay. Then the next reaction, that is the fifth category of reaction, that is the reactions with acid chlorides. Okay, reaction with acid chloride. Reaction with acid chloride. See here, this pyrrole on reaction with acid chloride. Acid chloride means CH3COCl. That is from acetic acid, one water will be eliminated on reaction with HCl. So it will be, we will be having CH3COCl. Okay, that is CH3COOH plus HCl. So here one molecule of water will be eliminated. So we will be having CH3COCl. Okay. So this pyrrole on reaction with CH3COCl, acid chloride. Okay. At 80 degrees Celsius. Pyrrole on reaction with acid chloride at 80 degrees Celsius. See, first of all, what happens is that this acid chloride will be adding to this position, that is from this position hydrogen, and this chlorine will be eliminated. Okay, so that the CH3CO group will be attached to this nitrogen atom. Okay, so at this nitrogen the COCH3 group will be attached. N, here it becomes COCH3. Okay, then see here at this position one hydrogen. Okay, it's there. So in the next step what happens is that on heating some rearrangement will be taking place. That means this hydrogen will be shifting to this position and the COCH3 group will be shifting to this position. Okay. Some rearrangement will be going on here while heating. That is, the hydrogen at the second position, it will be moving to this nitrogen atom and the CH3CO group will be moving to the second position. So this compound is N-acetyl pyrrole. N-acetyl pyrrole, that means this acetyl group, it is attached to this nitrogen atom, right? Isn't it? This CH3CO group, the linkage to the pyrrole ring, it is through the nitrogen. That is why this capital N, isn't it? So N-acetyl pyrrole. Then again, after rearrangement, the product will be like this. N. Then again, this hydrogen will be coming to this nitrogen atom and COCH3 will be going to the second position, COCH3. Okay. So this compound is, then again, this is the first position, second position. So the compound is 2-acetyl pyrrole. 2-acetyl pyrrole. Okay. Then the next reaction with methyl iodide. Sixth reaction with methyl iodide. A similar reaction just like the above reaction, that is, this is the pyrrole NH plus CH3I plus CH3I on heating up to 60 degrees Celsius. Okay. So here also this hydrogen and iodine will be eliminated so that the CH3 group will be coming to this nitrogen atom. So the product will be like this, N, again at this position CH3. Again on heating, what happens? Rearrangement takes place. That means this hydrogen will be moving to this nitrogen and the CH3 group will be moving to the second position so that the compound will be like this, N. Here it will be hydrogen, here it will be CH3. Okay. So this compound, it is 2-methyl pyrrole. 2-methyl pyrrole. And this compound, it is N-methyl pyrrole. That means the linkage of the methyl group is through the nitrogen atom. So this is N-methyl pyrrole. N-methyl pyrrole and 2-methyl pyrrole. Okay. So this is a similar reaction just like the reaction with acid chloride. Next is the ring opening reaction, sixth one. Ring opening reaction. See here, for ring opening, the reaction, it will be like this. That is, I am writing the pyrrole like this and NH plus. So here this pyrrole ring, it is reflexed with hydroxylamine. Okay, pyrrole, it is reflexed with hydroxylamine. Hydroxylamine, the formula is NH2OH. It is reflexed with 2 molecules of hydroxylamine. So what happens is that this bond will be breaking at this particular position. So the product will be like this. See here, how many carbon atoms? 1, 2, 3, 4. 4 carbon atoms. So that means it is a derivative of succinic acid or succinaldehyde like that. So the product will be like this, CH2, single bond CH, double bond NOH, again CH2, single bond CH, double bond NOH. So this compound is succinaldehyde dioxide. Succinaldehyde dioxide. Succinaldehyde dioxide. Okay. So this is the reaction and the byproduct, it is ammonia. So here at this position the bond will be breaking and at this that means the product will be like this. It is an oxime, that is double bond NOH is there. So CH2 single bond CH double bond NOH, CH2 CH double bond NOH. So this is succinaldehyde dioxide. Okay. Then the next reaction, the seventh reaction, that is the ring expansion. Ring expansion reaction. See here, a ring expansion reaction, it will be taking place in presence of dichlorocarbene. Dichlorocarbene. you have studied the intermediate carbene, isn't it? Carbene intermediate, it will be like this, isn't it? It is a divalent species. This is carbene intermediate. So dichlorocarbene means these two hydrogens are replaced by two chlorine atoms. So dichlorocarbene means it will be, the structure will be like this, CCl2 with 2 electrons. Okay. So carbene is CH2 with 2 electrons. Dichlorocarbene means the hydrogens in carbene replaced by 2 chlorine atoms. So CCl2 with 2 electrons. Okay. So the reaction with dichlorocarbene, for that we will be taking the potassium salt of pyrrole. Okay. Potassium salt of pyrrole means this is pyrrole. So when treated with KOH, what happens is hydrogen plus KOH. So from this water will be eliminated. So the remaining will be K plus and N minus, isn't it? NK, isn't it? So that will be the potassium salt of pyrrole. So I am writing the potassium salt of pyrrole N, then again K, okay, K plus N minus. So to this species, this CCl2 species will be adding. Okay, dichlorocarbene will be adding. See here, at this position there is a double bond, right? So this double bond will be breaking, and what happens is that 2 electrons will be made free, isn't it? While this bond breaks, here 1 electron and here 1 electron will be there, so that it will be forming a bond with this CCl2 molecule. Okay, so this will be forming a bond with this carbon atom. So the product will be like this, N K plus N minus, here a double bond, this double bond will be broken, and here a new bond is formed between this carbon atom. Okay, here at these two positions one bond will be formed, again CCl2 Cl. Okay, again in the next step what happens is that one Cl minus will be eliminated. That means one chlorine atom will be eliminated as Cl minus. So what happens? That means if this chlorine will be eliminated as Cl minus, this electron pair will be moving to this chlorine atom, so that this carbon will become electron deficient. So what happens? This bond will be shifting to this position. Okay, so this bond will be broken and this electron will be moving to this carbon atom. So what happens? This ring gets opened. Okay, this triangle or this bond will be broken and it will be becoming a 6-membered ring. Okay, so here what happens? Here a double bond will be formed. So again the product will be like this. At this position one bond here, then again at this position also, then here a nitrogen atom, then at this carbon position there one chlorine atom is there. Okay, so the ring gets expanded, isn't it? With the introduction of CCl2, or the CCl2 group is introduced into the pyrrole ring, so that this 5-membered ring gets expanded to a 6-membered ring. Okay, so here this double bond will be broken and another new bond will be formed between this carbon atom, and in the next step one chlorine will be eliminated as Cl minus. So this bond will be moving with this chlorine atom as a electron negative charge. Okay, so again this bond will be broken to adjust with the electron deficiency of this carbon atom. So this bond will be moving, so again a double bond will be formed. Okay, so this is the electron shift. And also see one more thing, this bond will be moving to this position, so that a double bond will be formed here, and this N minus charge will be moving to this position. Okay, so that at this position a double bond will be formed, here also a double bond will be formed. Hope you are clear. I will be saying it once more. At this position this double bond will be breaking and this CCl2 gets added up to form such a structure. Then in the next step Cl will be eliminated as Cl minus. So this electron pair will be moving with this chlorine atom and eliminated as Cl minus. Then to adjust the electron deficiency of this carbon atom, what happens? This bond will be broken and the electron pair will be shifted to this position, so that here a double bond will be formed and the ring got expanded to a 6-membered ring. Then again this negative charge on the nitrogen atom, it is moving to the ring, so that here a double bond is formed. Okay, so this is the structure, and this compound it is beta chloropyridine. Beta chloropyridine. beta chloropyridine. So this is the ring expansion reaction. So two types of reactions you had studied. The first one, that is the ring opening reaction, and the second one, that is the ring expansion reaction. That is a 5-membered ring, it is expanded to a 6-membered ring. Next is the oxidation reaction. Oxidation reaction. Oxidation reaction number 8. See here, pyrrole, NH. Pyrrole, it is oxidized using a very good oxidizing agent, that is CrO3 bar acetic acid chromic trioxide. Okay, bar acetic acid CH3 COOH. The product, it will be like this. This bond will be broken, both these bonds will be broken, and the product will be like this, NH. Here at this position double bond O, at this position also double bond O, here a double bond. Okay, so here oxidation takes place, that is at all these positions hydrogens are there. So this oxidation means it is the removal of hydrogen. So these hydrogens are removed, and instead this keto group will be introduced. Okay, so this is the compound formed on oxidation of using CrO3. And CrO3, it is chromic trioxide. Okay, chromic trioxide. And this compound, that is malenimide, MALENIMIDE, malenimide. Okay, malenimide, MALEINIMIDE, malenimide. So this is the compound formed on the oxidation. Okay, I think in the last year or before that year, one question is asked, what is the acid present in apple? Sour apple, I think. Okay, the acid present in sour apple, you have to find out the answer. Okay, so for today it will be, see here, then the next is the structure of pyrrole, and also some of the uses are there. Uses of pyrrole. First one, pyrrole, it is used as a commercial solvent. Pyrrole, it is used as a commercial solvent. Then second one, it is used for pharmaceuticals. That is in medicinal industry, it is used for pharmaceuticals. CEUTICALs. Okay, so these are the two important uses of pyrrole. Okay, so you have to write down the reactions and please upload it in the classroom itself. Okay. And in the next class we will be discussing the structure of pyrrole, and you have to go through the resonance concept as well as the molecular orbital concept. Both of them will is very important. It is an usually asked question, so it is very important, and also you have to study these reactions as well. Okay, so thank you.